Joanna Macy, the great environmental activist and systems ecologist, said that when faced with planetary crisis, there are three stories we can tell ourselves. Business as usual, in which we tell ourselves that some degree of damage is necessary for human progress. The great unraveling, in which we tell ourselves that mass ecosystem destruction is inevitable. And the great turning, in which we tell ourselves that evolving the way we live is the only way forward, and that we're at the beginning of one of the great projects in human history. On this podcast, we talk to people who are writing that third story, with their own work and their own lives. Mission-driven leaders who are dedicated to social and environmental impact at this critical moment for our species. Welcome to The Turning Point. On this episode of The Turning Point, we sit down with Zahra Hargens-Iliff, founder and CEO of Vessyll. Vessyll makes battery storage and energy management systems for commercial and industrial applications. Think bigger than Tesla Powerwall, but smaller than utility scale. Unlike a lot of people we meet in the energy space, Zahra has a background as a home builder, not as an engineer. So at a time when markets and energy policy are both in a state of chaos, I think it's good to get a grounded perspective on the real economics of the energy transition, the grid, and the impacts of policy on actual business owners. Just a note that in this episode, we talk about the tariffs on Chinese goods, which, as of this recording, have been temporarily lowered from 145 to 30%. But they were still at 145% when we recorded with Zahra. So, for business owners like her, the landscape continues to shift. Hope you enjoy this conversation with Zahra. Zahra Hargens-Iliff, welcome to The Turning Point.
Thank you. Thank you so much. Good to see you guys.
Good to see you. So, getting into it right away. In the energy space, it's hard to have a conversation these days where you don't immediately run into questions about the capacity of our grid and the oncoming tidal wave of energy demand. Where does battery storage fit into this puzzle?
Well, in the clean energy transition that we're currently in, you need a way to store the energy that's generated through renewable sources. Those renewable sources can be solar, wind, whichever, however, and you store that energy into batteries for immediate or future use.
Okay. And so in the renewable transition, are there certain sources or certain parts of the energy infrastructure where batteries are particularly needed?
They're needed in every part of the renewable transition. They are especially needed when we continue to increase the demand, the usage of more electricity. So as we move our homes and businesses to fully electric, it plays a major part in doing that.
Yeah, so when we're talking about growing demand over the next 20 to 30 years, what role do you see batteries playing overall in terms of how big of an investment we're going to need to make in this kind of technology as a system?
Yeah, well, we're absolutely going to need it. We cannot achieve the transition without batteries. They're a major component, and especially as things increase with AI and data centers and the storage of information on servers and how we utilize those systems, you need batteries to store the electricity to make that happen. There's no way around it. I want to cite something that has happened in Minnesota recently. So this is an alternative, and I would say a poor alternative to clean energy systems. So there is a data center going in at Beckers, Minnesota, and it's an Amazon data center. And they have proposed to put 250 diesel generators behind the facility in order to provide supplemental energy for that data center. That is not good for the environment. It's certainly not good for the people that live around there. We know that diesel generators are pollutants. They're loud. It is not, and 250 of them back to back, sitting in an open area is not good.
Okay, yeah, we've heard about the Beckers facility. So just to play a little devil's advocate here, you hear from certain people that to meet that energy demand, it can't be done entirely with renewables and storage. There has to be some natural gas or fossil fuel turbines to meet the full demand of some of these data centers. What would you say to those people, or what is not being included in that conversation?
I wish the conversation wasn't always an on-off switch. So it doesn't need to be either an or. I'm not a big fan of containerized battery units, but I would say that they would be a much better replacement for a diesel generator at that site. They might not meet all of the storage necessary, but they're going to get you just about there. So going back to kind of the on-off switch, I wish the conversations weren't around like we either have to go totally renewable or totally fossil. There's an in-between. This is the transition. We need to be paying attention to that transition in demanding that type of transition. Do you guys feel like you hear that kind of connotation when people speak about clean energy, like it has to be an automatic versus an introduction and an add-on until we totally get everyone there?
Yeah, I get very frustrated by conversations which are very black and white and very polarized. It's either going to be renewable, or it's going to be fossil, or it's going to be nuclear. Mm-hmm. Right? And if I'm putting a very big investment in something like a data center, right? I want to look at the whole mix that's going to give me the best cost, the best resilience, and the most efficient energy production and storage. And from what I've heard, from everything I've read, like you said, renewables and battery storage are going to be the fastest to build. They're going to be the most cost effective, and backing that up with storage to a very high percentage will get you almost all the way there for all of your energy demand needs. And maybe you need a little bit of natural gas turbine at the end to fill whatever gaps might come up in an extreme edge case situation. Yeah. Right? Because these things need to be online 24/7. So ostensibly,
and I think
yes.
We need to stop thinking about it as being we're not going to get there unless we do it 100% from the jump. It's going to be a gradual increase. And I think the thoughts around, well, we're not even going to try until we can get 100% there. That's ridiculous. Like, this is going to prolong the transition for another 50 years with that kind of mindset.
So, Zahra, can I ask a question here then? So, one of the things that I've heard on a number of occasions is, it's the age of the grid, right? And like the infrastructure of the grid itself. And one of the challenges with renewables is that the grid has a hard time kind of making all these things meet in the middle. So could you talk a little bit about the infrastructure of the grid itself, and then how batteries either help or hurt the role that the grid's infrastructure is going to play in this energy transition?
Yeah, definitely. So I'm not a utilities expert, but what I do know is we're dealing with the same technology as of lines running to our homes and buildings that is coming from a power plant and being piped hundreds of miles away. We know that renewables are going to help with the stability of the grid. That is 100%. We are an asset for them. Now, has that been worked out in every single utility on how to incorporate those assets? No. More attention needs to be paid to that. And that is the responsibility of utilities. It's partially the responsibility of the regulators, the legislators, to demand that the utilities do that. That the regulated utility monopoly make sure that they are including these new technologies and innovation into their, let's be nice and say, older system. Mm-hmm. Unless we have their buy-in, we can't make this transition. So they've got to play nice, and we've got to play nice as well with them. And I wish it was more a collaborative effort. I'm just going to say that. I love utility. We all love electricity, okay? We like that our homes and businesses have that benefit. But there needs to be a more collaborative effort between utility and private renewables market right now. That's not happening.
All right. Well, let's assume the best of people. And let's say that we're moving toward that collaboration. Could you give us an example of what a good collaboration between utilities and private producers like you might look like?
Yeah, I've been on a couple working groups that was actually started through state departments. Actually, Commerce was one of them that had a working group where it had utility, it had private market, and it was more around building the incentives the state was going to enact. I actually feel for the utility in this transition because they have a really monumental job in making sure that they are providing safe, continuous power. That's no small feat. And within an aging infrastructure. I mean, that's a lot to concentrate on. But what we need to have is we need to have the engineers, for example, that work in Vessyll, the engineers that's working in solar, in other areas, and get those engineers in a room with utility engineers and just work out how this is going to happen. The assets, I mean, we know what's available right now. We know what solar's providing. We know the highest technology in batteries and inverters, what's going on right now. But how they all fit together well and provide safe, continuous, uninterruptible power would be the mission. It can be done. But right now, I don't see a lot of avenues for those kind of conversations to be had.
So just out of curiosity, in a world where those conversations are being had, what would that look like?
It's going to have to do a lot with the controls and the communication. It's going to be around how our inverters are speaking with their physical assets and how that energy is deployed into what level so that it's safely distributed throughout the grids and literally out into the lines and into our houses and in community.
Okay. That
Am I
makes sense.
answering that question?
Yeah. No,
okay.
That makes sense. Because where I'm trying to take us is I want to hear a little bit more about specifically the technology that Vessyll is introducing into the system. And so maybe you could start by giving us a little primer on different types of battery storage and then specifically the solution that Vessyll is offering.
Okay. The main three types of battery storage where you will see them deployed is in your home. So an example of that is like an LG or a Tesla Powerwall that's primarily used for your electric vehicle, powering that up quicker. You'll see it at the CNI, the commercial industrial space. That's my sweet spot, and which has become a cost savings tool, which is great for businesses. And then at the utility scale. So that's going to be literally batteries at the power plant and helping with storing energy there.
You mentioned cost saving in the commercial and industrial space. How does that cost saving work?
So businesses usually have a high demand. They have large electricity bills, very common. I mean, we quote on businesses that have $25,000 a month in electrical costs, running motors, running, servers, all the equipment in your building, lights, everything. And when we pair most commonly with solar. So rooftop solar batteries can, depending on the size of the system, it can reduce your energy costs by 70% more. Depends on how large you build it, how many solar panels you put up and how many batteries, how large your energy storage system is at site. So that is a cost savings tool. I mean, that's directly off the bottom line. We're seeing ROIs in 4 to 6 years. These renewables are actually mechanicals. I mean, that's how I've always seen them. These are mechanicals to our homes and businesses. So very similar to like an HVAC or a furnace. And you're not seeing those kind of ROIs on other systems, other mechanicals. It's a very quick return. And especially with the current incentives, the Inflation Reduction Act incentives, where you can, at the minimum, get 30% off of a system.
Well, so I'm wondering if we can just take a quick step back, Zahra, for the listener who might not be aware, and I would even put myself in this category. That's a huge cost savings in short order, and that's a big line item on a company's P&L, right?
Yeah.
Can you tell us why are these companies paying so much? Maybe you're going to talk a little bit about, peak usage and how that works, and then why does a system like a battery storage system, like one you're offering in the C&I space, why does that reduce it so drastically, so quickly?
Often businesses will have a spike in energy. So let's use an example is someone comes into the business in the morning, they flick on all the lights, they turn on all the machines, and you have a spike of energy just from nowhere, like, oof, goes up. At that point that it spiked, the utility is going to go, you spiked in your usage, we're going to charge you a demand charge. Not so long ago, I quoted out on a company who had about $20,000 a month in electrical bills, and this demand charge was $12,000. So when you add $12,000 to your 20, you got $32,000. That is a lot of money unexpected. Okay, so to eliminate the demand charge, batteries deploy at the point that you are entering into a spike of energy, and it's going to smooth out that sine wave. It's going to give you a clean sine wave, and it's going to prevent the spike. So you aren't going to get that demand charge. Those spikes also can not be good for some of your motors, electronics that you're running as well. That's not always good for the entire load of the building. But that is where we're seeing the most cost savings, is managing the demand charges. Also, some equipment cannot handle spikes of energy. Not good for imaging. Another thing that's not good for imaging is when you have a power outage, let's say at a medical clinic, it takes a bit for the generators to start ramping up, to start going. And if you are using MRI equipment, imaging, radiology, you need a fast deployment of energy, and that's what batteries can do in 5 milliseconds that a generator can't do. There's servers, definitely these data centers, they need quick deployment of energy. And you're only going to achieve that through batteries and the inverters to deploy that energy.
And so it's harder for the grid to supply those spikes of energy, part because
Yes.
I don't know the engineering of it, but because
Yeah.
it's more work for the grid to push that energy out to your facility in short order, and that's why they're charging more for it, right?
Exactly. Yeah.
So is it fair to say that that's not only saving money, but also saving overall energy usage in the system?
Yes, exactly.
Okay.
And it's going to help, and having these batteries at site is not going to increase the demand from the grid. And that's why we contribute to grid stability. We're not taxing it. We're not drawing more from it. We are the supplemental ingredient for that kind of circumstance.
Right. So saving significant money to the end user, saving on overall demand to the system, right? And reducing stress in the system.
Yes.
Amazing. And then
Yes.
on top of that, if you're pairing with renewables on site, right, not only are you reducing demand and stress, but you're also sourcing from a clean source on top of that.
Exactly. And I
So
should
all
hire
that-
you, Justin. Yeah.
People used to pay me for this
Yeah. Okay. Thank you.
once
You're good
upon a
at it.
time. Yeah, unfortunately, I was
Good at it.
using it to sell cars and put more greenhouse gases in the air back in the day.
No, that's not good. Not good. That's not good. A clean energy system is you generate, you store, and you use all on site. We are moving. This is the future of how we are going to generate energy, power for ourselves, and use it. It's going to be moving to a distributed system, localized system. So people will have batteries in their homes. A neighborhood in the alley could have a shed that has a battery energy storage system. The homes would have solar on the rooftops. You're generating it. It goes in, it's stored in the battery, and it's distributed out. Yeah.
I want to be a part of that future. So what's the resistance to that future happening now? Why can't my apartment building have that?
I know, right? Well, first I'd like to say we are 100% going. That is the future. That is where we're going. These, power plants 100 miles away, piping it out, coming through wires above ground. And don't even get me started on that. It's the same technology since early.
Yes.
Not the young one's definition of 1900s, like the really old 1900s, like 19. Yeah. This is 100% where we're going. It is moving there. It's just how quickly, and we do have an issue with our current technology. That's just real. The amount of real estate that is on your apartment building's rooftop cannot probably power. I'm just going to make a general assumption that it
Sure.
cannot generate enough energy for the uses of the entire building. So especially as much solar as they can get on the rooftop, and then you have batteries in the mechanical room or however large that battery system is, that's going to help run the building and potentially store extra if it's possible and move to a clean energy system. The technology is getting better all the time, but it just cannot generate the amount of energy that every single resident would need.
But to your point,
get you quite far.
yeah,
And
to your
then
point,
we're
it
back
doesn't-
to that original. Yeah.
Right. Doesn't have to be all or nothing. If 50% of my building could be powered renewably and with storage, right? They'd be my owner, the owner of this building would be saving money and reducing
saving
stress
money.
on the grid and improving
Exactly.
reliability for all the residents.
Right. It is just a win-win-win. And I get frustrated with the kind of wait-see. I get a lot of like, well, what's the latest battery technology that's coming? And I often say, we have it right now. We just need to deploy it. Works really well. We have other countries that have been deploying these same systems that we call really innovative for the 15 years. I'll use Australia as an example. I think it's 30% of their businesses have rooftop solar. I think it's about 33% of homes have rooftop solar. 15% of homes have batteries. They're so far ahead of us that they're on a secondary battery market. So they're at the point where they have batteries at their home or business, and they've had them for 4 years, and like, they'll last longer, 15 or 20. Like, I'm going to get new ones. I'll sell them on the secondary market. We are nowhere near there. And they've been doing the same lithium iron phosphate batteries that I use in the energy storage system. They've been using that for 15 years, which is fantastic for us because we get to understand how they perform and the capacity levels. So it's really good for us. And I have an Australian working partner that has actually saved me from early on mistakes that we would have made. And they have been a second set of eyes for me on projects and have said, oh, you got to tweak this and tweak that because you're going to run into problems with this. And it's amazing.
Yeah, that's a good story. It's frustrating to hear that as a country, the United States is lagging behind. I mean, we love to view ourselves as forerunners in technology, but it's so clear that we're behind the times in this space. And to me, it shouldn't be political. Anyone who's American should be frustrated about the fact that we're lagging in what is clearly the future of energy.
Exactly. We're just delaying it.
Yeah.
For monetary purposes is all I can say. I don't even know.
Yeah. So this is clearly a topic of passion for you. I'm wondering if we could pivot just a little bit and hear about how you got into the space to begin with. What's the Vessyll story?
I got introduced to batteries through construction. So I started off with Adam doing renovation.
Adam, your husband.
Yes, my husband and my co-partner, Adam. The classic come up. You start renovating, then you move to new construction, that stepway in construction. Always loved to build things. Fascinated with materials. So sustainable, durable materials for homes and structures. And really fascinated by what's happening behind the walls. Like, how does everything fit together? How is everything working? Because it's really satisfying when you can get those things. You can take all these different components together, and then you can figure out how to make them work efficiently together, and then hand over this beautiful, well-run product to a user who gets to geek out on using it or enjoy living and using the things that you built. That's really fun. I love it. So I don't have a traditional pathway. A lot of people in my industry are engineers, or they have come from, the technologies have come from a university lab maybe. So I don't have a traditional path, but I'm very passionate about it. And that interest, you can't quite get away from or can't stop thinking about is my course. And I self-taught on a lot, which is grueling. I mean, because some of these white papers and materials I have to read, they are written for engineers. So, I mean, a paper that might take somebody an hour to read is going to take me, 5 hours because I really have to dive into it and dig a little bit deeper because I don't have some of that formal education. But I don't mind it.
So I can identify with reading a lot of academic papers and struggling through them. What's your motivation? Why did you persist to come up with this product that was going to take you so much time and effort?
The why is strange for me to answer, other than to say that it's an interest I just couldn't let go. If you would have told me 10 years ago, you're going to like batteries, that's so weird. I don't know why. I don't know why I like it. I like it. I like building the systems. I like working with engineers. I love working with the trades. I love working with electricians that actually install the systems. I just love the whole concept of bringing multiple teams together, and we're all going to get together and we're going to figure it out. We're going to figure it out on this really cool thing. Batteries are very, very important to clean energy system. I mean, you can't do it without batteries. And I don't think a lot of people know that. You know, they think like, oh, clean energy, that means solar, wind. No, there's huge, battery play a huge component in it. And also the inverters of the system, the controls. It's going to be really cool. The data and the way that we're going to be able to understand how energy feeds through different assets. I don't think that's probably going to sound exciting to very many people, but for some reason, to me, that is really exciting.
Well, I think you're hitting on something that is probably just in the water, right? Like most of us aren't thinking about when we flip on our light switch or we turn on the blender.
Yeah.
We're not thinking about all the things that have gone into making that possible. Yeah. And so it's kind of this, like electricity in general, just it's an easy thing to just not think about. It just kind of exists underneath the surface. But I think part of what I'm hearing you name is that, and I translate everything into some sort of nature analogy. It sounds like batteries are like a keystone species, right? Like you've got the grid, you've got the energy production, you've got the energy storage, you've got the conversion, you've got all these different components that make up the energy sector or system, and that batteries are this kind of like cornerstone piece or this keystone species in making that transition possible into this like new energy ecosystem. And I think that's something that's really important for the listeners to understand. Is, because if I can jump back a chapter in the conversation, you're saying, look, this is an essential part of, and this is where we're going, but there are also roadblocks, right? And Justin surfaced that question, like, what are the barriers to making this transition? And I'm sure we could have a litany of those things. But I think the first one is just like being educated about it, right? And as a homeowner who has taken the leap, for lack of a better term, to put solar on my house, I would have loved to include a battery along with it, but affordability was something that, kind of killed the deal. And I was like, well, I'm going to put as big of an array as possible on my house from an energy production standpoint, and I'm going to forgo the storage just because that's what I valued at the time. So I'm curious if we could pivot a moment. But could you talk about some of like the barriers and the limitations to making this transition? I mean, we've talked in previous conversations, you've talked about, how federal funds are often part of the capital stack. Yeah. I'm sure that just general awareness and education and understanding is part. You could maybe have this conversation on two different levels. What are some of the macro roadblocks? And then specifically within your like commercial and industrial space, what are some of the roadblocks?
Okay. I'd just like to touch on just one thing about what you said, Ian. Is that the first time you have experienced living in a building with solar?
Technically, yes.
Okay. I'm going to give you some context to what I'm saying. Is that I often hear that people are surprised that their solar cannot do or give the amount of energy that they assumed it would. And as in, on a basic level, there's some people that did not understand even that the solar would not provide the energy round the clock type scenario.
Yeah, I think the education and the customer service that I received was atrocious, I would say, right? And the only thing that I brought to the table was my own interest and previous research, and then, friends and family, of which there were a small few who had chosen to go the solar route prior. And so I was just going off the context of what I knew. But in terms of the educational process, I wouldn't really have said there was an educational process. It was just whatever was included in the sales process. And then I had already made the decision. I was the easiest sale possible because I'd already made the decision that we were going to do it. I didn't need any convincing, which I think speaks to another barrier, right? Which is the green premium. Like I was actively having the conversation in my head and in my family with my wife. Technically, we can afford to do this, and there are others that can't. And so we have the responsibility to do this because we're in a position financially to at least be able to consider it, you know? And so I think we have the responsibility to consider it. But there was no education or contextual like, hey, here's how this is going to work. Here's how much is going to be provided by your solar. Here's how much is going to come from, you know, the grid or your current utility provider. And if there was, I either A, didn't understand it and totally forgot, or B, it just was a very, very, very small part of the onboarding process.
Right, right. And that's the great thing that's going to be happening with the VPPs, and also what can happen with controls is that what you generate, we're going to be able to tell exactly how much you're feeding back into the grid and that how much you're spreading to your neighbors. It's going to get really clear. Right now it's a little bit hazy with utility as far as like how much do you generate that you use yours and then the rest goes back. What can happen is if and how much you're contributing to the grid. That gets into a whole nother conversation because once you figure that out, that's going to change rates. Because not only now are you a consumer, you're actually a contributor. You're selling your own energy. So that's a whole nother space for utility that I'm sure is a huge challenge. And one other thing I want to touch on is that I think for a lot of people, you don't recognize how important electricity is until you lose it. And you lose it for a significant amount of time. Now, us, in my younger years, I'm going to tell you, I have gone through not having electricity because it had been cut off. Bills, okay? So that's happened to me before. But I've also experienced not having electricity when I was living in New Zealand and there was an earthquake in Christchurch. That time I lived in Lake Wanaka in the South Island, but Christchurch had a 7.8 magnitude earthquake and people did not have, you know, water, electricity for a significant amount of time, almost a week. And until you've gone through that kind of experience, you start to realize how important having electricity is. And I got my first glimpse of that in building. I mean, it used to be a celebration day when everything's in and, you know, you're using, but full on, everything's commissioned up and powered up. And that just changes the game. But so until you have to survive without it, I think you really understand how important it is. And then you start having those thoughts like, where does it come from? How can I make sure I don't go through this? The generator's great, but it's a pain, it's expensive, it's loud, all those things. And there's alternatives. I know that the more battery energy storage we build and the better we get at it and materials enhance, just that, those things alone are going to bring down the costs. And every day we are looking for how do we make this more affordable? What can we move to? Yeah.
Okay. Speaking of affordable, as someone who is a CEO of a growing business in an emergent space that is being impacted by the federal tariffs, right? I'd love to hear your thoughts on, first of all, how you as a leader are dealing with that uncertainty. And two, I'd love for you to just, you know, let it fly and talk to us about what's going on in your industry, in your space, and how those tariffs are impacting you and battery producers in general.
Right. So we are greatly impacted. And the battery modules, 90+% of them are made in China. The producers of modules here are Tesla primarily, and Tesla only sells to themselves. And even the battery cylindrical or prismatic pouches, they're getting those from China. So not even 100% is made here. Battery production, battery cells, 97% plus are made in China. We do not make them here. So there's no alternative for me. I understand politically how it would be advantageous if people bought materials from America that were produced here. I get that. most of the other components we do purchase, and we are Build America, Buy America compliant. Okay. But I don't understand quite the methodology when I cannot purchase the materials in the United States. So what am I to do? I'm paying 145% tariff on the modules. My supplier's going to eat some of that. I'm going to eat some of that. And then the price of the system's going to go up. It could be absolutely detrimental and will stop progress. And until I have an alternative, and I can only get it there, I don't understand. I wish there was incentives for battery module manufacturing in the United States. Even if we started absolutely today to build a manufacturing plant, we could not get one up and running for a year. That's just the fastest we can get the four walls up and generally going. And then we have the problem of catching up with the 10 years advanced manufacturing knowledge that China has. So a good solid module's out the door a good 3 to 5 years. So that's where we're at. And it's devastating. You know, we've all got supply stateside that we're running through, but it's debilitating. As a business owner, what that's going to make me do, if this doesn't change soon, it's going to make me get more conservative than I already am, and I'm going to stop spending money. So I'm going to size down. I'm going to start letting people go. I'm going to stop contracting outside of the business. I'm just going to tear down to survivability. It just makes the money that we generate and spread out absolutely go insular, and we're going to stop. We're going to slow way down just to survive. Been on the phone with people in our pipeline. There's a lot of projects that have stopped. They're on pause. Like, we can't do it. We can't afford you. And it's not just us. It's when the project's paired with solar, they're in the same circumstance. So they can't have the project, even if we eat part of the tariff, they can't have the project double in size. These budgets are tight to begin with. Just makes everything stop. So I hope that the current administration knows that. I'm really hoping the first buddy, Elon Musk, who's in the energy storage game, communicates that to his best friend. And those conversations are being had because we need him to communicate that.
And given everything you've told us about the needs of the entire national energy infrastructure, it seems pretty nonsensical to basically put a massive tax on a critical piece of that infrastructure at a time when demand is clearly on its way up.
Right. It's shocking. It's shocking. I haven't been through anything like this in my, business life. I'm 51, working forever. I've never seen anything like this before. I would understand if there was some kind of governmental incentives towards manufacturing or some kind of tax incentives for businesses during this time, but there's nothing that I see that's going to help get us through this. So, it's a very strange time, and it's got to change soon, I hope.
Yes, and thanks for introducing me to the term "first buddy." Hadn't
Yes.
heard that yet.
Oh, you haven't? That's a common one. That's
No,
one that's out there.
I'm adopting that. Yeah, I guess you've already answered this. I guess if the goal was really to onshore manufacturing of critical elements of our infrastructure, then it seems like there would be a strategy to include that, right?
Another issue with manufacturing is the literally machines that would make the cylindrical cell batteries or the other parts, some other parts in the module, the machines are made in China. So we have to start from zero. We've got to figure out how to make the machines that make the parts that make the battery. I mean, a lot of the components from the grid are also made in China. So all this infrastructure work that needs to be done on the existing systems, it's going to just, I don't know where, it just seems really bad all across the board. But
Right.
Yeah, we've got a heavy lift to get there. But it's good that the light has been shone on this is really, it's not a very good position to be in, period.
In some ways, I think it harkens back to, one of the first things that you mentioned in this conversation, which is, in order to make this progress, what we really need is coalition building, and we need cross-sector and cross-industry collaboration. And you use that term insular in terms of how this is impacting your business. Yeah. And I think, to extrapolate on that, it sounds like if many other businesses start to do the same thing and go insular, then that's not only going to be bad for the energy transition as a whole, but it's also going to kind of erode that kind of like unseen, unspoken foundation, which facilitates collaboration, right?
Exactly.
Which is just being in communication with one another and like actually doing business and having exposure to new deals and different people and different solutions. And so if all those things start to slow down, when the flywheel comes to a stop, I'm no engineer, but like it takes a lot of energy to boot it back up again.
It does.
And so it's interesting timing, and regardless of people's political opinions, it just lends more credence to the importance of continuing to have these conversations and continuing to collaborate so that we can try and get creative. Because, as a species, and this is me trying to lift us back up here from a positivity standpoint, we're pretty great at surviving when we put our minds to it. And, at a macro scale, we're up against it right now, and we will be for the next several decades and, potentially more than a century. But it's going to be this facilitation, right? This back and forth exchange between humans and businesses and industries and sectors that's going to create the possibility for us to be successful in the transition. And capitalism often gets a bad rap in the environmental space. And I totally understand why. And I've been that person as well. But one of the assets of capitalism is that, the markets that demonstrate demand are that's where the fuel goes to the fire.
Oh, definitely.
And so if we can find a way to make that possible, regardless of what's happening at the administrative level, we can still theoretically make progress. It's just about getting creative and figuring out what it's going to take.
Right. I think you're exactly right. I think that it's during the slowdown that if the attention is not putting towards deploying more systems, right? Reaching out to more people, securing those projects, deploying the actual assets, it does make you, if you can survive, it's going to make us concentrate more on the R&D and focus on some R&D projects that were there. I actually had a conversation this morning on a similar topic that we can pay more attention to this now. We have more time. I have the ability to do that because we're kind of a lean and mean model. I don't know how other companies are structured for survival. But I think you're exactly right, Ian. We are a community of builders and engineers, and so we'll figure it out. And everyone I'm working with is committed to this, and this is a lifelong venture. We just have to survive economically, but we will continue to innovate.
Right.
If we're in the room together, we're going to innovate.
Yeah. In the spirit of collaboration, Zahra, there are two questions we do at the end of every interview with our guests and allow them to speak directly to the audience. So the first one is, what is one resource or form of support that would help you move the mission forward?
I would like people listening to bring up clean energy in different spaces. If it's like a cocktail party or, a dinner party, and be like, have you heard of this? So just get the conversation going. Do you guys have anything? You might be pleasantly surprised on what they have in their homes or their businesses. And I would say maybe if you're at a school function or at maybe a school board meeting, you could ask the administration, hey, why isn't there solar on the roof? Why aren't there batteries? Where are we doing? What are we doing here? At the job, in a meeting, hey, have we thought about these systems? They're a cost savings tool. So just speak about it. In speaking about it, you're going to learn more about it. That's always a benefit. And then you're just spreading the word on what this is.
All right, and you may have already answered this, but what is one thing you'd want people to know or want people to do on their own that would make a difference?
Want people to know. Well, I do just want people to know that these systems exist. We are moving in a good direction. We are in the middle of a transition. Although you can't see it sometimes, it's actually happening. It's not if it's happening, it's just at what speed can we accelerate that?
Couldn't say it better myself.
Thank you.
Zahra Hargens-Iliff, thanks for being on The Turning Point.
Thank you. So good talking to you guys.
Thank you, Zahra.
Okay.
All right. Big thanks to Zahra for being our guest today, and thanks to you for listening. If you want to learn more about Vessyll and their energy storage systems, check them out at vessyll.com. That's VESSYLL.com. 2 S's, 2 L's. As always, thanks for the work that you do, and we'll see you next time on The Turning Point.